So my talk today is called Integration of Technical Writing Instruction into STEM Courses at Kettering University. Now, I should let you know that this talk has been presented previously, originally at the Lilly Conference in October of last year. So the Lilly Conference is a teaching conference that faculty get together at in order to improve their teaching and their learning. So there are some collaborators in this work that I should let you know about. Of course, I'm listed on the left there. We have Dr. David Duranchik from the University of Michigan Flint, who is teaching in the biology department. And we also have Professor Jackie Knoll from Mott Community College in the Humanities Division, who is part of this work as well. So by way of introduction, what this really is an experience report outlining the results of 2 years of work. So this work was done through a faculty learning community, also known as FLC, of the QuadPod Consortium. The QuadPod itself is a professional development group for higher education faculty based at U of M Flint. And I'd like to take this opportunity to thank the U of M Flint for hosting the faculty learning communities. All 4 institutes of higher education in Flint participate: ourselves, U of M Flint, Mott, and Baker. So my particular FLC is focused on incorporating technical writing assignments into science and engineering courses. So the gist of the problem is listed there in the middle. How do we improve student writing in STEM courses? How do we make the writing better? How do we incorporate writing into our science and engineering courses? So at the end of this session, participants are going to be able to do a few things. The first thing is create a technical writing assignment prompt. The second is improve their grading rubrics. And the third is to design a peer review process. So this is an outline of my talk. I'm going to talk motivation, why we want to do this anyway, a little bit of background, a little bit of related work, a case study associated with a mechanical engineering 500 level course, and I'm going to summarize the whole thing. So, motivation. Why is it important to teach technical writing in STEM courses anyway? So we have a need for STEM professionals with strong communication skills. On the other hand, STEM programs tend to de-emphasize the teaching of technical writing. So we have a kind of conflict that we have going on here. The courses that are offered usually do not address technical writing in the STEM disciplines, which leads students inadequately prepared to write well, and STEM faculty not knowing really what to do about it. So what I have done for you people here is I have given an image of a typical freshman composition textbook. This one is called How to Write for the World of Work. And I selected it because when I was a student at Kettering, this is my own undergraduate institution. It was called something different then. This is a much more updated version of the textbook. But I still actually look at mine. It was a very good book. But that would be kind of typical in engineering programs and physical science programs where you would have, say, a freshman composition course, and maybe in some programs you might have a second course later, but in general you'll have one course in writing that occurs early on. So we have an inadequacy here, or a conflict. So to address this inadequacy, what we did here in our faculty learning community was implement technical writing assignments into 2 different STEM courses. We got guidance from a longtime writing instructor. That's where Professor Knoll comes in from Mott Community College. So she's an expert in composition and rhetoric, and she helped Dr. Duranchik and myself implement these assignments into our STEM courses. So as part of that, we created an assignment prompt, a grading rubric, and a peer review process that resulted in greatly improved student writing. So just for fun, I decided to include a couple of images here of the kind of work we want our students to be able to produce. We could have given many examples. So the one in the middle there is an SAE event paper that I did regarding my smart tire research, and the one on the right-hand side there is a paper done by Dr. Duranchik on the subject of vitamin A as a regulator of such and such. And unfortunately, I know nothing about biology, but I trust it's very, very good. If the thing doesn't occur in a car, chances are I don't know about it. But the point here is that we want our students to produce work like this. We need our students to be able to produce work like this. So that's the background on the whole thing. So we did look into the literature that is available on this subject, and I just want to highlight a couple of the journal articles that we looked at. The first one is that first row sort of highlighted in kind of blue colors. And that article had to do with a study in an engineering program. And what they found out or recommended as a result of that study is that writing should be incorporated into the entire engineering curriculum, culminating with a literature review assignment in senior year. What they found out through surveying their students is that outsourcing writing stigmatizes it as something other than the quote-unquote real curriculum. Now, what do they and I mean by that? What do we mean by outsourcing? Normally, in a traditional science or engineering program, that freshman composition course is outsourced to a different department, let's say compared to the mainstream engineering department that the student is studying in. That's a typical kind of thing. What the researchers found in this study is engineering students tend to think of those courses that are taught by other departments as not being real somehow, or maybe something that they can de-emphasize a little bit, not focus on so much. Now, the study found that those foundational courses are absolutely critical. We have to have them, but we also need to incorporate writing into the engineering program as it goes on, and just not have that one single or one or two courses for English composition. And then we have another journal article here that's highlighted in black and gray, so you have the reference information if you'd like to look at it. But on a different subject, these researchers found that peer-evaluated students perform better at writing than those who are graded solely by instructors or teaching assistants. So what we found out here, and this kind of just summarizes a lot of the results, is that we really need to have technical writing incorporated into our engineering curriculum directly into the curriculum, and we need to have peer review as part of the process. So those are some of the things we tried to do in our FLC. So this is the case study that I'm involved in. This is a mechanical engineering 500 level course. It is called Mech 546 Vehicle Systems Dynamics. Now, this is a so-called mezzanine course, primarily taken by graduate students. Mezzanine is supposed to be something like in between, so most of the students in the classroom are grads, and then we'll have some senior level upperclassmen as well in the room. So that gives you an idea of what the course is like. I have taught it 4 times by the end of this term with embedded technical writing assignments, 3 times completely with the assignments, and I'm going to report on that today. So in my course, I have 2 major writing assignments. The first one is a literature review paper, and that's what I'm going to focus on here. The second one is a final course project paper. So my goals for the literature review paper are I want to familiarize the students with the conventions of writing in their field. That is the single most important goal of the assignment. The next goal that I have is I want to improve the student writing skills, both basic and advanced. Basic skills I want to improve are grammar, spelling, organization. Advanced, I'm talking about research synthesis. So very broad, overarching kind of goals for this assignment. And that last bullet there on goals, I'm going to admit to you, is a tiny bit selfish. I want to drastically improve the quality of the final course project paper. I know full well that if the first paper the students ever write is the last one, I'm probably not going to get very good results. So I want to have some upfront practice in technical writing in the course, and that's where the literature review paper comes in. So what I have done here is presented a few images of what the core of the course is really about. So what we're doing is really representing the responses of our ground vehicles using a mathematical and dynamic systems approach. So the course actually is pretty hardcore on the math side. Now, just because we're doing technical writing doesn't mean we can get out of the math. So we get to do both in vehicle dynamics. So I want to talk a little bit of the version history on the assignment prompt. So the first time I did this course, I had a briefed prompt that's lacking instructions. We're just going to look at it really quick here. So we're not going to read this, but I'm going to summarize it for you. You can kind of get the feeling. It's not very long. It's maybe half a page long. And I'll tell you what it says. It basically says, give me a literature review in 2 weeks. That's basically what it says. It doesn't say a lot. Okay, that's where I started. That's where the prompt started out. And if we can, okay, there we go. So I want to, so I have my little, highlight my little picture there, which is our chariot from the ancient world. This brief assignment prompt resulted in very poor submissions, sometimes very strange. I'll give you an example. One student for his course project was doing an assignment or a project on a technical innovation in the design of shock absorbers. So what he did in his literature review was gave me a review of something like the history of the shock absorber. It belonged on the Learning Channel or the History Channel. So he had something like, you know, this thing was invented by human beings in 3000 BC, and it was believed to be the first shock absorber. So he didn't understand the assignment, and I actually talked to him about it, because I thought, well, maybe he's yanking my chain. Maybe he doesn't want to do this, and he's just writing some stuff, right? So I talked to him, and I recognized that he really and truly did not understand the nature of the assignment. So that led me to the next version of the assignment prompt here. And it is a longer prompt with a two parts to it. Now, again, we're not going to read it, but you can see at the second level here, it's 2.5 pages long. There's much more detail. And there's much detailed instruction in terms of what is expected, what a literature review means in this context. So there's a lot of detail, so we get around that problem. And there's an additional innovation in it. And you'll see it here in this table. Now, this table was recommended by Professor Knoll of Mott College. It's called the Sources Summary. And you can see there, going left to right on the columns, that there's source number 1, source number 2, source number 3. And the idea there is you will take a primary source, like a conference paper, like a journal article. You'll enter that information there. And you can see going down the rows, you have concept 1, concept 2, concept 3. And those are different ideas or concepts that you're investigating as part of your literature review. So the idea is you go kind of cross the fields, let's say where source 1 and concept 1 match, and you're going to write in a little summary or annotated bibliography about what source 1 had to say about concept number 1. And in this version of the assignment, I had the students hand in both the sources summary and the actual literature review itself. Now, this worked much better. I got much better responses from the students, but I found that the students got a little bit hung up in the sources summary itself. So I asked them to do it in Excel, because for some reason engineers seem to love Microsoft Excel. I don't know why that is. But I told them to do it in Excel. And that version, in that course, I had students asking me things like, well, what if one of the sources doesn't talk about one of the concepts? What do I do with that field? And I would say, well, just leave it blank. And they say, well, I don't want to leave it blank. So there was some kind of discomfort associated with leaving fields blank. So there was a lot of conversations on that. And where I got to in the third iteration of where it is now, there's an intermediate length prompt. It's not exactly 2 pages long. It still has a description of the assignment and the summary. I do not make the summary mandatory for them to have any more, but I explain that it's a way that they can organize their thoughts on the assignment. In addition to that, I provide examples of real review articles written by Kettering University faculty. I put that up on Blackboard so the students can see that there really is such a thing as a review article. You could have that published in a scientific journal if you read a lot of literature and review it, not just a few, like in this assignment, but there really is such a thing. So they have real examples of what a real literature review paper looks like. Now, on the subject of the grading rubric, so where I started with was on the left. I call it my backyard engineering style rubric. That's my name for it. This was homemade. So I made up this homemade rubric. It was in Excel, and I'm just going to pull it up really quick here. So this one here, while we're waiting for it to come up, took a long time and it was kind of subjective. So let's take a look at what I had. So I had some major categories like format, writing, quality, tables, etc. For example, let's take a look at the format. Compatibility of assignment with the template, 20 points, and then comments I would fill out. Okay, so I would go and manually fill out comments there. Let's get rid of that. Now, this process took a long time for me. I spent a long time writing comments, and frankly, to some extent, it was subjective. I'll give you an example. The 20 points for template conformity. Some students got 18, some students got 19. If I'm really honest with myself, I don't know why some students got 18 and some students got 19. It was subjective, and I needed something else. So again, I turned to the experts, and I turned to our own in-house expert in English composition and rhetoric, which is Dr. Denise Stodola, and she recommended something different in terms of a rubric. So there's going to be some formal name for it, but I'm an engineer, so I call this the English composition style. You can see again that we have different rows indicating different areas, categories of assessment, content, audience, organization, coherence, etc. And then you can see, looking at the columns, that there's ranges, A, B, C, D, F, and 0. For example, content 0 would be because the project was not submitted or it exhibited plagiarism. And then there's other guidelines to grade the students in a certain range. Now, this was an early version. It has received iterations, both by myself and I imagine with Dr. Stodola, but it gives you an idea of how the grading rubric works at this point from my perspective in the course. I implemented in Blackboard. I always give credit where credit's due, so it says credit Stodola right there in Blackboard so the students know where it comes from. This is better. It has significantly reduced my grading time, and I think it's more fair to the students now. And I have to use something like this because, let's face it, our classes at Kettering are getting bigger. Every single term they're getting bigger in mechanical engineering, not just in vehicle dynamics class. So this is working, and I have to do something like this. But once I settled on it, I thought to myself, but is this how technical writing is scored in the real world? And if I'm honest, the answer is no. It's not done that way. So I implemented a peer review process to answer that concern. So it is modeled on the Society of Automotive Engineers conference paper blind review process, which I am very familiar with as an organizer for SAE conferences and also being involved in an SAE journal as an editorial board member. This is a classroom simulation of what graduate students will be faced with in the very near future. Many of our grads are expected to do SAE event papers as part of their programs. So this is very near future. This is not off in the future, in the far or mid-future for our students. In this case, the instructor, that's me, acts as a session organizer or editor in facilitating the reviews. So my literature review assignment at this point has 3 parts. So the first part is the students have to submit a draft paper, and that is evaluated by me on a credit, no credit basis. So you may be wondering, what do I do in the evaluation? I try to make this as realistic as I can. I do basically the exact same things I do with the students in the classroom that I do in the real world. So I do some sanity checks and smell checks on those draft papers. I make sure that they're complete. I make sure that they're on topic. I make sure that there's no bad words. I make sure that there's no racial slurs, nothing weird and funny that would prevent that from being put into the review process. If it passes those basic kind of smell checks, then I put it into the process and give the students credit for having completed the draft paper. Then there is a peer review process that's blind and is based on the SAE event paper rubric. I'm going to bring it up and show it to you. It is not exactly the same as the SAE process, but it's similar. So I give the students a rubric sheet in Microsoft Word like this. They have to enter the paper number. They have to enter the paper title. So it's a little form with fields that they can fill out. There are judgment bases such as innovation, integrity, presentation, quality, conclusions. Each one of these things they have to rate numerically out of 10. And there are some questions that are intended to get them thinking about the paper they've read. For example, integrity. Is prior work of others adequately credited? For example, presentation. Does the introductory section explain the motivation and orient the reader? So there's some guidelines. In addition to those questions for thought, there are numerical scoring guidelines. So 1 to 2 would be many major weaknesses, 9 to 10 is no significant weaknesses, etc. So they can go through and look at the scoring guidelines when they are doing their own peer reviews. Then I ask them to rate the manuscript, one of 4 ways. Approved means just period, it's just really good as it stands. Approved if modified with minor revisions, approved if modified with major revisions, and disapproved meaning basically they're not going to be able to fix it up within the time we have remaining in this class. And then I ask them to enter their comments, which is mandatory. Often comments are the most useful thing for authors here in the classroom and in the real world. So they have to write comments about what they read in the paper. Now, again, I evaluate the peer reviews themselves on a credit, no credit basis. What am I looking for? I'm looking for the exact same things that I'm looking for in the real world. I want this to be on topic. I want it to be reasonable. There are some reasons in the real world and the classroom where I will sit or on a review and hold it. For example, sometimes a person may be excessively harsh or rude. Usually I will sit on a review like that and go and seek other reviews. But if the students have done a good job with the reviews, then they get credit and we go forward with the process. So the last thing we have to do here is submit a final paper. They do have to make revisions. They have to provide a detailed response report that addresses every single concern that was brought up by the reviewers. Now, what I have done here is I have provided a real example from my life on Blackboard so the students can see how this is really done. So I didn't pick I didn't pick a paper that I had written that got like superb reviews and it's like everything's coming up roses. I picked a paper that I had written that had 3 reviews from, they're blind, I don't know who those people were, right? And they thoroughly criticized my paper, and then I, of course, had to respond to every single concern that they brought up and wrote a detailed revision report. And I put that up as an example on Blackboard so the students can see how this is done, and also that they understand that this is not just some academic exercise I've come up with because I've run out of technical assignments in vehicle dynamics. There's no end to the mathematical assignments I can come up with in vehicle dynamics. We're doing this because we need to know how to do it, and it's important. So in an overarching sense, what are the positives, what are the negatives of this process? One thing that worked well is I feel like I have more engaged students. Interestingly, some students volunteered to review more papers than they had been assigned. Now, I didn't survey them. I haven't got to that point. Why? But there were some students that were interested in it. They wanted to do more reviews, so they took well to it. This process has helped me identify plagiarism. The first time I deployed it, within an hour and a half, I got one student catch another student cheating. Now, he took the assignment very seriously. What he did was he looked at the references, he looked them up that were on the reference list, and he actually circled the paragraphs that were copied wholesale by the other student. So it helped me identify plagiarism in that particular case. Also, it helps the students understand that it's not just me, the instructor, that's a meanie when it comes to copying other people. Your peers don't like that either. That review was rather straightforward, let's put it that way. It wasn't harsh, but it was straightforward. So it's good for the students to get that from other students. It's not just me that doesn't want that. So ultimately, this has resulted in better quality final papers. And it has reduced my instructor grading time. So what's the downside of this whole thing? It has a long assignment time frame. Right now, it's about 3.5 weeks from start to finish. And as you know, at Kettering, we have like 10, 11-week terms, and it's hard to fit something like that into a course here. So it's time consuming. That's one of the downsides. And one other thing that's time consuming is right now I have kind of a time consuming manual way of making this a blind process. So what I do is I create identifying numbers for students using the MATLAB random function. And what I can do is, I can mass download submissions from Blackboard, which I do, but Blackboard stubbornly insists on attaching student names and numbers to assignments, which is not going to work for a peer review process. So right now I manually rename those things with those identifying numbers. Of course there's going to be a way to automate this process, I just don't have it yet. So right now there's some kind of time-consuming logistics associated with it. So to summarize what I've done here, or I should say what we have done, that's more fair. So we've embedded technical writing assignments into a 500 level mechanical engineering course at Kettering, and it's got some positive results. Better student work, improved grading efficiency. And the same model was applied to a 400 level biology course at U of M Flint with similar goals and outcomes. Dr. Duranchik's course is called Mammalian Physiology. That's, if I pronounce that right, mammalian physiology. I asked him, is it about mammals? He says it's about humans. I say, why don't you call it human physiology? He says, I don't know, but it's called mammalian physiology. And he has basically implemented this same process in mammalian physiology class. So lessons learned, first of all, set clear expectations for students in writing assignment prompts, or frankly any prompt, to get around the problem of the history of the shock absorber and bizarre results like that. Employ time-saving rubrics when grading writing assignments. That's been working out well. And we want to really deploy a realistic peer review process that is based on an authentic paper review procedure in a STEM field. So I am the corresponding author on this work for our FLC, so if you have questions about it, you're welcome to contact me offline later.